Exploring the Mysteries of Mars, a Space Odyssey. In the vast cosmos, a fascinating world orbits beyond the twinkling stars, a planet of mystery and wonder, Mars. Since the dawn of human civilization, the red planet has captivated the imagination, prompting profound questions about life beyond Earth and the potential for interplanetary colonization. Through the centuries, Mars has been the target of exploration, from telescopic observations to robotic and human missions, each revealing a little more about the hidden secrets of this distant world. In ancient mythology, Mars was associated with the Roman god of war, symbolizing its red color with the blood spilled in battle. But as science advanced, Mars became more than a distant deity. It became a tangible destination for human exploration. The first telescopic observations revealed intriguing features, such as polar ice caps and dark patches that changed with the seasons. These observations fueled speculation about the possibility of life on Mars, inspiring writers, scientists, and dreamers. In the 20th century, the space age brought with it a new chapter in the exploration of Mars. The first robotic missions, such as the Mariner and Viking probes, provided detailed images and crucial scientific data. It was discovered that Mars was a dynamic world, with valleys carved by ancient rivers, towering mountains, and even traces of frozen water beneath its dusty surface. However, the search for life on Mars remained inconclusive, further fueling popular imagination. In the early 21st century, humanity took a bold leap by sending manned missions toward Mars. The first pioneering expeditions faced monumental challenges, from interplanetary travel to survival in a hostile environment. However, each step on Martian soil represented a triumph of human ingenuity over cosmic adversity. Martian settlers built underground habitats, cultivated food in protected greenhouses, and explored the vast horizons of the red planet in search of answers to the fundamental questions of existence. As the human presence on Mars grew, so did the understanding of its history and potential future. Scientists discovered evidence of ancient lakes and seas, suggesting that Mars once had a warmer, wetter climate conducive to life as we know it. The search for signs of microbial life continued, with probes and rovers exploring ancient craters and deep valleys in search of traces of primitive organisms. Each discovery fueled hope that life, in some form, could have arisen on Mars, shedding light on the mysteries of the origin of life in the cosmos. Meanwhile, the colonization of Mars unleashed a technological and social revolution on Earth. New propulsion and environmental sustainability technologies were developed to support human presence in an alien environment. Mars's natural resources, such as ice and minerals, were exploited to sustain the growing needs of the colony and drive interplanetary economy. At the same time, a new Martian culture flourished, blending terrestrial traditions with new practices adapted to life on a distant world. However, the challenges of living on Mars were never underestimated. Violent dust storms and extreme temperatures posed constant threats to the safety of colonists. Dependence on Earth's resources and the overwhelming distance between the two worlds demanded a delicate balance between autonomy and interdependence. However, despite the challenges, the colonists of Mars remained resilient, inspired by the grandeur of the challenge and the promise of a bright Martian future. Meanwhile, the eyes of humanity turned to the horizon, beyond Mars. Other worlds in the solar system, such as Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, also sparked interest as potential habitats for extraterrestrial life. Distant stars, with their unique solar systems, whispered promises of even more extraordinary discoveries beyond the confines of the solar system. However, even as we gaze at the stars, Mars remains a beacon of hope and exploration in the cosmos. It is a constant reminder of human perseverance and our capacity to transcend the boundaries of the unknown. As we continue to explore and colonize space, Mars will remain a testament to the curiosity and exploratory spirit that propel us to the stars. And so, the saga of Mars continues, an epic odyssey of discovery and rediscovery, tracing the limits of the possible and unraveling the mysteries of the universe. Mars, the cosmic journey beyond borders. In a vast and mysterious universe, Mars remains one of the most intriguing destinations for human exploration. The red planet, as it is called for its characteristic color, has been the subject of fascination and speculation for centuries. With a desert-like surface and extreme climate, Mars challenges our understanding of the cosmos and encourages us to seek answers to some of the most fundamental questions about life and the universe. The journey to unravel the secrets of Mars began centuries ago, when ancient astronomers observed its movement in the night sky. The intense red color of Mars, resulting from the oxidation of iron on its surface, intrigued ancient civilizations and inspired myths and legends about gods of war and celestial rulers. However, it was only with the advent of modern astronomy that we truly began to understand the nature of this distant world. The first telescopic observations revealed intriguing features on the surface of Mars, including polar ice caps and patterns of dark spots that changed with the seasons. These observations fueled speculation about the presence of water and even life on Mars. In the 19th century, William Herschel's reflecting telescope revealed sharper details of the Martian surface, leading to heated debates about the possibility of artificial canals and advanced civilizations. However, it was only in the 20th century that the exploration of Mars truly took off. The first space probes, such as those in the Mariner series, provided the first close-up images of Mars, revealing a desolate landscape and craters marked by asteroid impacts. In 1976, NASA sent the Viking probes, the first to successfully land on the Martian surface. These missions were a milestone in the history of space exploration, providing detailed images of the surface and conducting experiments to search for microbial life. In the late 20th and early 21st centuries, robotic exploration of Mars entered a new era with the deployment of robotic rovers. Sojourner, Spirit, Opportunity, Curiosity, and Perseverance brought a new perspective to the study of the Red Planet, exploring its geology, climate, and potential past and present habitability. These rovers discovered compelling evidence of liquid water in the past and sites where microbial life could have survived. As robotic exploration of Mars advanced, plans also emerged to send humans to the Red Planet. NASA, SpaceX, and other space agencies and private companies began developing technologies for manned trips to Mars and the establishment of permanent bases. However, the challenges are enormous, from protection against cosmic radiation to the production of food and water in a hostile environment. The colonization of Mars represents a bold step for humanity, expanding our frontiers beyond our home planet. Martian settlers will face unprecedented challenges, but will also have the opportunity to shape a new world and contribute to our understanding of the cosmos. In the long term, Mars could serve as an outpost for human exploration of the solar system, a stepping stone for more distant missions, such as asteroids and planets beyond the asteroid belt. In addition to its scientific and exploratory potential, Mars has also captured the popular imagination as a setting for science fiction. Authors such as H.G. Wells, Ray Bradbury, and Kim Stanley Robinson imagine futures on Mars, from interstellar wars to utopian societies. These stories challenge us to think about what we might find on Mars and how it could shape our future as a species. As we continue to explore and colonize Mars, it is important to remember that we are only temporary visitors on a vast and ancient world. We must approach the exploration of Mars with humility and respect for its unique history and ecology. At the same time, we must keep alive our curiosity and imagination, for it is these qualities that propel us to reach for the stars and seek answers to the mysteries of the universe. Ultimately, Mars represents more than just a distant destination in the darkness of space. It is a symbol of our infinite capacity to dream, explore, and discover. As we gaze at the night sky and contemplate the mysteries of the universe, Mars remains a beacon of hope, reminding us that the impossible is only a matter of time and determination. And so, the cosmic journey beyond borders continues, with Mars as our guide and inspiration. 50 real curiosities about Mars that few know. In the depths of the solar system, Mars rises as an enigmatic world, filled with secrets and mysteries that challenge our understanding of the cosmos. In this epic journey through Martian curiosities, we delve into the depths of the Red Planet, uncovering hidden truths and cosmic wonders that few know. The seasons on Mars are twice as long as on Earth due to the planet's elongated orbit around the Sun. Mars has the tallest mountain in the solar system, Olympus Mons, which rises to a height of 21.9 kilometers, nearly 3 times taller than Mount Everest. Valles Marineris, a gigantic rift on the Martian surface, is more extensive and deeper than Earth's Grand Canyon. Mars has 2 small moons, Phobos and Deimos, which are likely asteroids captured by the planet's gravity. Mars's atmosphere is mainly composed of carbon dioxide, making it extremely thin and unable to support life as we know it. Mars has a reddish color due to the presence of iron oxide, rust, on its surface. The average temperature on the Martian surface is about -63 degrees Celsius, making it one of the coldest places in the solar system. Mars has the largest dust storm in the solar system, capable of enveloping the entire planet and lasting for months. The polar ice caps of Mars are primarily composed of water ice, with a layer of carbon dioxide ice on top. Mars exhibits seasonal features on its surface, including the growth and retreat of polar ice caps and the formation of carbon dioxide clouds during winter. There is evidence that Mars once had rivers, lakes, and even oceans on its surface in the distant past. Scientists have discovered clay mineral deposits on Mars, suggesting that the planet could have hosted environments favorable to microbial life. Mars has a small axial tilt similar to Earth's, resulting in similar, though more extreme, seasons. Mars has a much lower average elevation than Earth, with most of its surface covered by plains and craters. Auroras on Mars are caused by the interaction between solar particles and the thin Martian atmosphere. Sand dunes on Mars are often shaped by the wind and can extend for hundreds of kilometers. Valleys on Mars are often formed by ancient water flows, suggesting a rich and dynamic Martian geological history. Mars has a rotation speed similar to Earth's, with a Martian day lasting about 24 hours and 37 minutes. The surface of Mars is marked by a wide variety of geological formations, including extinct volcanoes, deep canyons, and impact craters. NASA's Viking 1 probe was the first to land on Mars in 1976, conducting experiments to search for signs of life in Martian soil. The Opportunity rover holds the record for operational longevity on Mars, operating for over 14 years until losing contact in 2018. The Curiosity mission, launched in 2011, discovered evidence that Mars once had the conditions necessary to support microbial life. The Perseverance rover, launched in 2020, is equipped with a helicopter named Ingenuity, which has successfully flown in the Martian atmosphere. The European Space Agency and Russian Roscosmos have plans to send a joint mission to collect Martian soil samples and bring them back to Earth. Jezero crater, where the Perseverance rover landed, is considered one of the most promising sites to search for signs of ancient life on Mars. The first man-made object to reach the Martian surface was the Soviet Marsnik 1 probe in 1960. NASA's Mars Reconnaissance Orbiter has been providing high-resolution images of the Martian surface, helping scientists identify sites of interest for future missions. NASA is exploring the possibility of using autonomous robots to build habitats and infrastructure on Mars ahead of the arrival of human colonists. The Indian Space Research Organisation successfully launched the Mars Orbiter mission in 2013, becoming the fourth space agency to reach Mars. Mars has an active volcanic history, with evidence of recent volcanic eruptions in some regions of the planet. ESA's Mars Express orbiter discovered evidence of liquid water beneath the surface of Mars, suggesting the presence of a large underground reservoir. Mars has a unique geological history, with the northern and southern hemispheres having different altitudes and ages. Dust on Mars is mainly composed of basalt and iron oxides, giving the Martian landscape its distinctive reddish color. The soil on Mars is rich in minerals such as iron oxides, silicates, and sulfates, suggesting a complex geological history. Mars has such a thin atmosphere that it is unable to protect the planet's surface from cosmic radiation, posing a challenge for life and human exploration. ISRO's Mars Orbiter mission, launched in 2013, successfully entered Martian orbit and began studying the planet's atmosphere and surface. Mars has a diverse topography, including mountains, plains, valleys, and impact craters. ESA's Mars Express orbiter identified sulfate salt deposits on the Martian surface, suggesting the presence of liquid water in the past. Mars has a very thin ozone layer compared to Earth's, making the surface more vulnerable to solar ultraviolet radiation. NASA's MAVEN spacecraft is studying the upper atmosphere of Mars to understand how it interacts with solar wind and loses gas to space. NASA plans to launch the Mars Sample Return mission in collaboration with ESA, which will bring Martian soil samples back to Earth for the first time. Mars has a water cycle similar to Earth's, with polar ice evaporation, cloud formation, and occasional precipitation in the form of snow or rain. NASA's MAVEN spacecraft discovered that the loss of water from Mars to space is accelerated during solar storms when solar wind hits the Martian atmosphere with greater force. NASA is developing advanced propulsion technologies, such as ion engines and nuclear propulsion, to enable faster and more efficient trips to Mars. Mars has a shorter Martian day than an Earth day, lasting 24 hours, 39 minutes, and 35 seconds. NASA's Phoenix lander, launched in 2007, discovered water ice beneath the surface of Mars near the poles. Mars has unique geological features, including the Tharsis Bulge, a massive volcanic plateau that is home to Olympus Mons. The Mars Reconnaissance Orbiter identified chloride salt deposits on the Martian surface, suggesting the presence of ancient brine lakes. Mars has a dynamic atmosphere, with dust storms, clouds, and seasonal changes. NASA is developing technologies to produce oxygen from Martian atmospheric carbon dioxide, which could be used for breathing and propulsion on future manned missions. Thus, as Mars continues to challenge our understanding and inspire our imagination, each new discovery reveals more about the richness and complexity of this distant world, setting the stage for future explorations and deepening our knowledge of the cosmos.